In this problem, the doctor's order is for 15 milligram Coumadin. On hand are tablets containing 2.5 milligrams. The question is asking how many tablets should be given to fill this order. So our goal will be to convert our order into tablets. To begin the dimensional analysis, we will start with the doctor's orders expressed as a fraction shown here with a denominator of 1. We'll multiply it by a conversion factor fraction such that will allow us to cancel out milligrams. To do so, we need to have a milligram unit in the denominator to cancel out our current order, which is in milligram. The problem gives us the relationship between milligrams for this medication and a tablet. 2.5 milligrams is equal to 1 tablet. Arranging equivalent values in fractional form gives us our conversion factor fraction, which is a special 1. Multiplying by 1 does not change a value but allows us to convert from one unit to another. When multiplying fractions, if there's a common factor in the numerator and the denominator, since it has a value of 1, they cancel out. This leaves us with our order now in tablets, which is our goal. To finalize our answer and multiply fractions together, we'll multiply the numerators together to give us the new numerator and multiply the denominators together to give us the new denominator. Simplifying final step will be numerator divided by denominator, which gives us an answer of 6 tablets to fill this order. In this next problem, the doctor orders 1.5 grams of ampicillin. On hand are capsules containing 250 milligrams. Our problem here is to answer this order in capsules. To begin, we'll start with the doctor's order expressed as a fraction of 1.5 grams over the implied understood denominator of 1. The problem relates capsules to milligrams. However, the order starts as grams. Before we can convert milligrams to capsules, we need to convert our grams into milligrams. So a preliminary step will be to set up a conversion factor fraction such that grams will cancel out and convert it into milligrams. The relationship between grams and milligrams is that 1 gram is equal to 1,000 milligrams. Placing the grams in the denominator and the equivalent value of 1,000 milligrams in the numerator gives us a special 1. Multiplying by 1 does not change a value, but in this case will allow us to convert from grams into milligrams. Moving forward then, we can then use the information given for the medication availability of capsules to milligrams. We want to eliminate milligrams, which is the current form of the order, so the next conversion factor fraction needs to have milligrams in the denominator. Taking these equivalent values and expressing them as our conversion fraction, we'll place 250 milligrams in the denominator, 1 capsule, an equivalent value, in the numerator. When multiplying fractions again, we can cancel out common factors, which in this case is milligrams, leaving us with the unit of capsules, which that was the ultimate goal here. To simplify fractions, we'll multiply the numerators together, 1.5 times 1,000 times 1, and multiply the denominators together to give us the new numerator and denominator respectively. Final step will be to perform the division of numerator 1500 divided by 250 to give us a final answer of 6 capsules to fill this order correctly.